All right, good afternoon, everybody. Welcome. Welcome to the second in our AEOP Apprenticeships and Fellowship Speaker Series for this summer, 2023. My name is Donna Burnett. I'm the director of the AEOP Apprenticeships and Fellowships Administrative Office at the Rochester Institute of Technology. And one of my great pleasures is I get to host the webinar series this summer. So today, before we get started, I'd like to go over a few housekeeping matters. Number one, please be checking your emails if you are a current apprentice or fellow. We're sending about twice weekly. We'll send some updates with information about the upcoming speaker series. Tomorrow, you're going to get invited to our Learning Hub, and there'll be also a video tutorial there, so you don't have to sit through another webinar. So please check that out in your personal time and ask us if you have any questions. There was a question that came up about attendance at our webinars. We do not take attendance. These are strongly encouraged because they're designed to support you, and they're one of the benefits of being part of the Apprenticeships and Fellowships program. But we know that you are very busy in the laboratory. So if you have an experiment or a project that is coming during this time, we understand that. We will make our videos available. Right now, we are uploading them to a common space where you can access them. They're not going to be on YouTube until we package them and format them. So that will be sometime, but you'll get to access them by tomorrow. You will have access to the first and second videos. Okay, so I've covered, check your emails, do great in your apprenticeship and fellowship positions. Please look out for messages also from Kiara McGinnis and Miranda Salisbury. They're our outreach specialists. They'll be checking in with you, and do not hesitate to reach out with any questions. We're here to assist you. So today in our session, we have both the Q&A and the chat function. So the chat is for more informal questions and comments and conversations. The Q&A is for questions that are going to go to our speakers, or in some cases, they're answered immediately by the other folks on the RIT team. If they have the answer for you, they'll get to them. But we will, because we can't have voices on the recorded videos on YouTube, we do turn off the attendees' microphones and videos for the recorded portion of the session. So you will write your question into the Q&A, and it will be voiced by someone who's managing the Q&A. So please, thank you for working with us. That has to do with youth protection regulations. So thank you so much. So with that, if you have any questions or comments or having trouble accessing, please put a note into the chat and it will be addressed for you. So with that, I'm going to start by introducing our speakers today. It is my pleasure to introduce a panel of scholars and researchers from the Northern Arizona University. We have Dr. Naomi Lee, we have Taj Moore, Ashley Steinberg, and Ryan Iwahiro Miller. And they are faculty, graduate student, undergraduate students in the Department of Chemistry and Biochemistry. And I believe you guys all work in a research group together. Is that correct? All right, so with that, I'm just going to turn things over to your group here. I know you prepared a presentation and we'll have time for lots of questions at the end. So you should be able to share screen, and Heather will manage who is spotlighted. Thank you.
And so then in our lab, we use two different types of vaccines platforms. So you might have heard with COVID-19, the mRNA vaccine, right? That's considered one type of vaccine platform. We use different types of vaccine platforms. So virus-like particles are actually what your current HPV vaccines are made out of. We also use a newer technology called self-assembling peptides. There aren't any current vaccines right now on the market. We're trying to assess how maybe this might be an alternative to some of the current vaccines out there. It has some good pros and cons related to it. And then once we have a vaccine, we do all our studies, we make them. We primarily work in animals with mice, and then we immunize mice and do other types of studies. And so this is just a quick snapshot. Again, it's that community bench where the communities come to us and say, we have this disease that's prevalent. Can you help us in either designing a vaccine, or more on the public health side, looking at other factors that might be associated with the disease. Okay, so I'm going to turn it over quickly for the next student to introduce ourselves, and then I think we can get into questions. So Ashley.
Hi, I'm Ashley Steinberg. I am one of Dr. Lee's graduate students. I'm doing a master's in chemistry. I took a slightly longer path to get here than most of the other students. So I graduated from high school in 2001 in Memphis. And then I decided that I wanted to be a paramedic because it sounded like fun. So I was in Austin. I went to paramedic school. I worked for quite a while in Milam County, Texas, which is a very rural area outside of Austin. Then I decided that being on a helicopter would be fun. So I came here and to Flagstaff. Sorry, I forget that you guys aren't local. I came to Flagstaff and I worked for the hospital here and flew on their aircraft for quite a while, about 10 years. And during that time, several things happened that kind of made me decide that I needed to make some career changes. One, I got cancer and had to do chemo. So being in a physically demanding career really wasn't working out. And then COVID happened and the world went crazy and healthcare changed. So I made the decision that I wasn't going to do that anymore. And I completed my undergraduate degree at NAU in biology. And during that time, I realized that research sounded fun. And I got introduced to Dr. Lee, and she was nice enough to let me join the lab. And I have been with her for the last year. This is my last year of the master's. So hopefully next year I will go on to a PhD somewhere. I don't know where, but we'll see where I end up. So my research is based on using silver nanoclusters for antibiotic alternatives for diseases which have become resistant to current therapies. Basically, what we want to do is we want to take silver nanoclusters, which are a whole bunch of little silver ions that are held together with lipoic acid. And you can see those in the picture. They're the gray image that look like little suns. And we want to attach them with a peptide to this beta sheet platform. That's the big rectangle in the center. And that is what is made of the self-assembling peptides that Dr. Lee was talking about. So the combination of all this will be highly effective at combating antimicrobial diseases, and it won't be selective against one or the other. You guys might be familiar that antibiotics, they're generally tailored to a specific type of disease. So this would be like a broad spectrum antimicrobial. And the use of the self-assembling peptides is going to allow us to put as many silver nanoclusters on the delivery device as we can. So that's the short version of my research.
I guess it's my turn. Hello, my name is Ryan Iwahiro Miller. I'm getting a Bachelor's of Science in Chemistry. I'm also getting a Bachelor's of Science in Biomedical Science. And I'm just going to go a little bit into how I kind of fell into this portion of my life. I'm going to start things off with my high school experience because it's a little bit more recent and pretty much the majority of my educational background up to this point. So in high school, I didn't really know what I wanted to do in college. It was kind of crazy because until probably my first semester in high school, I wanted to do electrical engineering because that's what my dad did when he was in college. And in high school, I did something called the Green Academy, which was an engineering-based kind of class pathway where they have set up classes for you to learn engineering. So that really kind of set me up to want to become an electrical engineer in college. I also did advanced media and video production where I was in a pretty much a good morning like broadcast for the school where we went over school news. I made little videos kind of like you see on the news about things going on in school, about sports, and about just things that I felt like were necessary to be able to give back to the community or give to the school for like little educational pieces. But the last semester of my high school, I wanted to go and I was like starting to get ready to apply for colleges, and I decided to actually apply for biomedical science. So I applied to NAU and I started to get my degree in biomedical science. And I honestly kind of wasn't really interested into the science portion of STEM. And it was kind of a weird turning point when I took a microbiology class, where the microbiology class really got me interested in academia, and it really got me interested in research, taking microbiology, learning about how interesting microbiology could be, also taking the lab where you're actually doing hands-on like Petri dishes, all of the classic things that you want to be doing in the lab. And this really set me up to want to get deeper and deeper into academia and deeper into research. So after that, I decided to apply for some labs. I applied for a genetic research lab. I also applied to be an organic chemistry TA. I also applied to be a TA for the next upcoming microbiology class. But the next step is when I actually became an organic chemistry lab TA. And this helped me find my STEM niche in chemistry. The organic chemistry class really taught me to think differently about science. Because before I didn't really have the greatest view about science. I didn't really have a great appreciation for science. But organic chemistry taught me that I could be pretty good at science. And it taught me how to, I guess, become a better scientist, enhancing my own techniques. And then also becoming an OChem TA, it taught me that I kind of want to help educate the next generation, because seeing how students trying to figure out how to apply all of these new things that they're learning in the lecture and then applying it to actual techniques was really interesting and really a great experience for me to help connect those two things together for them. And the second semester of my junior year, I was accepted into Dr. Lee's lab, where now I am working on increasing alpha helical content of apolipoprotein C3 peptide antigens on VLPs. I know it's a mouthful right now, but I'll get more into it with the future slides. But now going into the future, I plan on applying for a master's or a PhD program coming up this winter. And then hopefully I can get into a program where I can get a master's or a PhD in biochemistry or organic chemistry. And then once I achieve those goals, I plan on going back into academia, becoming a professor, and then conducting my own research lab, just like Dr. Lee does. But now I'm going to go a little bit more into the research that I'm conducting. So the project I'm working on, it's going to be a mouthful, but it's going to be lowering cardiovascular disease risk factors by displaying murine proteins, apolipoprotein C3 variants on virus-like particles to generate antibodies. So I know it's a lot. I'm going to try to break it down, but I'm going to read the hypothesis first. So to combat heart disease, a protein called apolipoprotein C3, or APOC3, has been identified as a potential treatment due to its interactions with the fats in your blood. We plan on studying rodent-rodent interactions by dividing the rodent APOC3 into 6 peptide structures and displaying them onto Q beta virus-like proteins. So in our project, we are hypothesizing that if we take these portions of a protein, split them down into small little peptides, and connect them onto the outside of a virus-like protein, and we display them like antigen. So for like COVID, I think on a few slides before, Dr. Lee had the picture of COVID where it has the little red spikes on the outside. That's what we're trying to act as our peptides onto and have them display like that. So then your body wants to react to it just like it would to a virus and create antibodies for that section. So hopefully if we can have your body create those antibodies to the APOC3 peptide, or that portion of the peptide, it would pretty much have APOC3 protein not interact with something called very low density lipoprotein, which is correlated with lower high density lipoprotein, or the good cholesterol, going back to like the Cheerio commercials where they talk about good cholesterol and bad cholesterol, higher that count, and also lowering triglyceride counts. So how are we going to do this? How are we going to be creating these peptides? How are we going to take those portions of the structure and then create them and then attach them onto the virus-like particles? So all of our peptides in the lab are based off of something called solid phase peptide synthesis. And for our peptide, for my peptide specifically, we have something called special side chain protecting groups on them. So the one that's, we have MMT on the lysine and ODMAB on the aspartic acid. What do these do? So they are only able to be removed with special chemicals that we put into the reaction. So MMT is only removed for under one type of chemical condition with only one type of chemical. And then it's going to be the same thing with ODMAB. This allows us to be able to remove them whenever we specifically want and only when we specifically want. So once we remove those in their respected specific chemical environments, we're then going to do something called an amide bond. So on the MMT is protecting an amine group, and the ODMAB is protecting what's called a carboxylic acid. And we're able to take the nitrogen from the amine group and the side oxygen of the carboxylic acid and put them together to be able to create alpha helical structure. So alpha helical structure for a protein is going to look something like DNA. When people have the classic DNA kind of raveled together look, that's what we're trying to achieve when we're connecting the two side chains from the lysine and the aspartic acid in hopes that we can get a better immunogenicity response when we attach it to the VLP. But once we get that alpha helical structure, we're going to remove it from that gray dot, which is called resin. We're going to purify it through something called chromatography. In our lab, we use HPLC, or high precision liquid chromatography. And then once we have it purified, we verified that we made what we made. We're going to attach it to the outside of a Q beta VLP, and hopefully we can inject some mice and get some good results. And that's all for me.
Okay, so it's my turn. So my name is Taj Moore. I am a master, going for my master's at NAU. And so I'll be discussing 2 slides. Well, we'll start off with my academic journey. So I graduated from Winter Rock High School, and this high school is located on the Navajo Reservation. And as you may or may not know, the Navajo Reservation is the large American Indian reservation. And so that's where I grew up. It borders Arizona, New Mexico, Utah, and the southern part of Colorado. And so that's where I grew up most of my life. And then, so I didn't have college in mind at all when I was a high school senior. I didn't, apply to schools. I just, I decided to work on my family's farm rather than go to college. So one day I told my parents that, and they're like, okay, bro, we'll still love you no matter what. But until 2 days after, my mom was like, you know what, let's go to the grocery store. And so, okay, let's go to the grocery store. And it's about like a 45-minute from my house, 45-minute drive from my house to the nearby major city, I guess. And so what she planned is to go disguise this small trip to the grocery store and enroll me to a community college. So that's what we did. And so she was like, you know what, just sign his application papers and, I want you to go to college. I was like, okay, I'll go to college, but if I don't like it, I can, just quit. And so the first 3 weeks, I didn't like it at all because it was very similar to a regular high school class, in my opinion. It's community college and whatever. And until I met a medical assistant professor. She was very brutal. She was very tough in her exams. She wanted precise answers, precise scientific notation, and I didn't really like it all. And so I started going to her office hours repeatedly, weekly, and starting conversations with her. And she inspired me to go into the medical field. And so with that motivation in mind, I transferred to NAU and completed my bachelor's in biomedical science. But from my freshman year to senior year, I started finding other research experiences. So as you may know, another high school or undergraduate program, summer program that I looked into is called Research Experience for Undergraduates. And so I did that for the 4 summer programs I did I did summer programs associated with the RAEU. And so, as you can see, I did research in biomedical engineering and mycology, infectious disease, and plants. And then for my senior year at NAU, I felt like taking a gap year, but I came across a couple of mentors that reached out, and they're associated with RISE, which stands for Research Incentive for Scientific Enhancement. With this grant, I'm able to continue my master journey and be fully funded by RISE. And with that, I got introduced with Dr. Lee, and she saw, potential in me and welcomed me into her lab, which I'm very thankful. And we decided my project. And so my project is developing a potential pancreatic cancer vaccine. I'll be using Q beta virus-like particles conjugated with epilipoprotein C1. So epilipoprotein is kind of associated with Ryan's research, so I'm be focused on C1 of epilipoprotein. And so my future plans in the upcoming months, I will be defending my thesis. And then after that, I'll be applying to MD, PhD programs. I will, if I'm, in a MD, PhD program, I will continue cancer and immunology research. and then earn my PhD in 2 years or so, or when I apply, and then earn my medical degree and begin my residency. And so this is the second part of my presentation slide. So this is my title of my research. So I want to increase the immunogenic properties of epilopoprotein peptide and then conjugate it onto virus-like particles to combat pancreatic cancer. In other words, I'll be supercharging this peptide vaccine to enhance immune response, basically. And so below is a diagram of what I am going to be doing. So on the left-hand side, it's a short epilopoprotein C1. I'll be combining it or conjugating it on a virus-like particle. And this will be a vaccine platform that I would be injecting into mice. And I guess my hypothesis is that using this this vaccine platform, it will promote cell death and then, making a more immunogenic response, and which will help pancreatic cancer patients.
I just wanted to start by saying thank you. Thank you for not just telling us about your science, but telling us about your pathways. I hope that everybody here thinks back to their own story and finds a reason for how they got to where they are, and those people and that networks and those pivotal choices that we made. One thing that really stuck out for me in your talk, and it was common among all of you, is that you have values that aligned with the paths that you've taken. So can I just ask about that more directly? So what personal values helped you to choose the field or job you're pursuing? So I hear people wanting to go to be professors, faculty members. Taj, you mentioned wanting to go and become a medical doctor. And Naomi, you've chosen this path, mentoring students and bringing forth a whole group, a whole next generation. So what values of yours do you really call upon when making these choices?
I'll answer briefly and then I'll let them give their responses. And so I didn't talk about it, but my path looked very linear and easy and not a lot of obstacles, but it was actually filled with a lot, all the way from younger years growing up as a Native student on the reservation. But both my parents passed while I was in graduate school. And I say now, a lot of what I do is to honor my parents. And so honoring my people that I work for, and to try to do research that is impactful for them in many different aspects. So whether it's the STEM education and outreach or the actual research. So again, a lot of my values is honoring those that came before me and helping the next generation.
Thank you for that. Does anybody else want to share values that have shaped their path?
Mine are very similar to Dr. Lee's as well. It's been, I don't even know how to describe it, but seeing how cancer has affected my family, not only with me, but in other family members, because it's genetic in our family. That has really made me want to work in that area and try to prevent others from having to go through this.
I would like to join in and chime in. So when I was growing up on the Navajo reservation, there was a lack of professional STEM people when I was growing up. Though I would like to, increase the representation of, Native American professionals. And that's what I really, truly hold to my heart, is to make, to help other high school students that, that relate.
Thank you for sharing those. One of the themes this summer is going to be about being authentic in your pathway. I think we all see before us this message of it should be linear and it's all about competition and getting to the best, the best, the best. But by being authentic to your values and letting those inform your decisions, I suggest that you'll find greater satisfaction in your career path. So thank you for sharing those. So I was wondering if you can talk about the importance of networking and professional organizations and those type of communities and how they've shaped your pathways.
Well, again, I'll just highlight networking is how all of them got involved in my lab. So that was important because that was internal. And then externally, I like to go about this a little bit. We have a 100% success rate for every student that's come out of my lab to get accepted into MD, a PhD or a STEM type of career if they want to take like a gap year or something. And so a lot of that, again, has to do with the networking that they have done at conferences or as well with my internal network. But they can all talk about networking that they've done and maybe how that's helped them on their career path.
All right. So with that, remember your network isn't just who you meet. It can be through a friend or a lab mate, a colleague, your roommate, your partner, so you got to keep your options open, and you never know what's going to open. So Dr. Lee and I were able to connect, and I had opportunities available, and she had a network that could benefit from opportunities. So look what we're able to do together. And I just want to remind everybody about the AEOP Travel Fund. If you're an AEOP apprentice or fellow affiliate, there is a travel fund available for you that you can apply to go to a conference like ACES. And if you're a minor, it also includes funding for an adult to travel with you. So please be aware of that and take advantage of that resource. So there's a question here in the chat seems to be directed to Ashley. It says, how did you get to the National EMS Academy paramedic license?
So it's like any other school. You apply for it and you get accepted. I think they're based out of Louisiana, but they have a couple locations all around the Southeast. And it was a 2-year program, I think it was. So yeah, very, very, very simple process compared to PhD.
Thank you. So my follow-up question is, what do you wish you had known before getting into your fields or your pathways?
Again, the only thing for me is when I went to grad school to get my PhD in chemistry, I didn't even know about MD/PhD programs where you could get both. So I had already been well into my PhD program, and that is probably the one thing I might have done differently, is to go back and do an MD and a PhD.
Yeah, I was going off of Dr. Lee. I didn't even know it was even an option to even, do an MD and PhD program, because I was like so confused, how do I balance it all? And that brings me to I believe time management is really underappreciated. Like, you need to have a good time schedule. You need to have a good habits to be a well-established student.
I'm going to second what Taj said, especially going through my undergrad right now. I think one of the things I wish I would have told myself back when I first started my undergraduate was like, I wanted to take as many credits as I physically could just to get classes out of the way. And rather than like just kind of calming down and just trying to focus on my classes, focus on time management, teach myself those lively skills, because once you're in your undergrad, you're living as an adult and you're doing school. It's really, really hard. So I would say learn the time management skills, see what you value the most, and just focus on those things, because you're going to run out of time if you try to do everything.
I think I just wish that I had started this sooner. And I wish I had like 18 days in a week, because you never can get everything done. And yeah, sleep is important.
Thank you. I see one coming in from the Q&A. It says, what scholarships did you apply to or receive, if you feel like sharing? So we heard about the RISE program, which we posted a link to. We heard the mention of REUs, which we posted a link to. Are there any other funding sources that have really helped you along the way, or supports, financial supports?
So at NAU, our TA position is, it supports our tuition as well as gives us a stipend. So that's my main support. I gotten a couple scholarships, not as many as during the undergrad, but most of those were academic from honor societies, just scholarships from NAU, basically, is what I lived on.
So can someone explain especially for our high school audience, what a teaching assistantship or research assistantship is, just generically?
So what I have to do is I teach 2 of the organic chemistry lab sections. And so I do 2 sections a week. That's about 6 hours of teaching, I think. And then, of course, I have to do like all the grading and that goes along with it. But it's a bit of a time commitment, but it's worth it to have your tuition paid. They pay for my health insurance, and then you get a stipend on top of it, which is, you know, a small paycheck every 2 weeks to help out with, you know, gas, food, things like that. There's also the research assistantship, which I am not doing this year, maybe later. And that your stipend pays for you to do your research, essentially.
So there are various support ways when you're applying to graduate school that you'll be offered the opportunity to have to help cover tuition and other costs. So there's external funders that we've talked about, like the SMART Scholarship, and then there's internal to the universities you're applying to. So there's lots of opportunities if you keep your eyes open for them. So making educated networking so that you could be educated about those opportunities will widen your ability to receive one of them. So keep your eyes open there. Dr. Lee, did you use the reserves to help with school?
No, I was not that smart, and no. So if you go onto our lab website, we list the awards that all of the students have received, both internally
Nice.
and externally. So like Taj, who's not saying it, he received what the Cobell recently. And Ryan received an internal NAU. So if you're interested in chemistry, NAU has a lot of chemistry related scholarships. I think we give out about $100,000 each year. But no, I did not use the reserves. I already had my master's when I joined the military, and then they wouldn't pay for a PhD. So that's why I'm an officer now.
I would like to, if you guys are going from a community college to a university, I would like to mention a private scholarship. It's called Jack Can't Cook. Yeah, it's a really good scholarship.
So we'll get the link to that one in the chat. And I know at least there are other folks on this call who've done the community college pathway as well. And that can be, non-traditional pathways may not be popular in mainstream media, but they're popular among the folks that we see as very successful. So please, your pathway does not have to be the cookie cutter. There's a lot of ways to get to where you want to go, and it's your journey that creates you. I think that's a rock song, but I love hearing all the stories, and thank you for sharing them. I'm going to go on to the next one. So what has been the hardest point of your career education, and how did you navigate those things? I think Dr. Lee shared about the loss of her parents. Is there anything that the rest of the panelists can share about those pivot points in your lives?
Yeah, when I was the undergrad, I was very strict that it's only about school. It's only about school, because I was like interested in going to an MD program. And so I just mainly focused on school, but like, what else am I interested? Like, do I like running? Do I like working out? It's just, yeah, I believe for my pivot point was I was so focused on school, like I didn't really have that flexibility to discover who I am. And so that by sophomore year, I just found like it was my additional journey to find who I am. And yeah, after discovering who I actually am, it just helped me with my junior year and my senior year of undergrad.
And I think that points to mental health as well. So following on that, when it says, are TAs or RAs mostly for PhD candidates and very limited for master's students in general?
No. So there's different levels. So like Ryan is a TA as an undergrad, and he gets, I think it's an hourly pay for what he does to TA. Ashley, that covers, she teaches more, and that covers her tuition. And Taj is an RA, meaning he does research. And so it's all different levels. If you go into a PhD program, a lot of times your first 2 years while you're taking courses, you will be on an RA or a TA. Many times as a TA, like when I was a grad student, I did my first 2 years and I was taking courses, and I was also teaching as well. So it just really depends on the institutions where you go to. And so like Ryan, who is an undergrad TA, he's much cheaper to pay than to hire more faculty. So that's why grad students and undergrads are hired to be TAs of some sort for different classes, whether it's a lab or something else, because they're cheaper than what we are. And they get overseen by a faculty member.
And that's something that sometimes people consider when they're choosing a university to go to as an undergraduate. Are you going to be taught by faculty? Are you going to be taught by teaching assistants at what level? Or do you want to have the opportunity to teach? So it's a good thing to keep in mind when you're shopping for your education. I want to go back to something Taj said about running and figuring out who he was as a sophomore. How do you navigate work-life balance?
You just have to set a good schedule, I guess. I believe like going back to, having a good, time management skill is very crucial as an undergrad. So the way that I like to schedule mine is in the mornings, I like to mainly focus on academic work. And then in the afternoons, I give, myself the free time to do things I like to enjoy, like as a stress reliever. By the end, it will give me like a good sleep, I guess, to physically, tire myself out and give me that award, I guess, from, studying and all that stuff. So yeah, that's how I.
So my stress relief is on Friday nights, I destroy everybody in our lab in Mario Party and beat them mercilessly. So that's pretty much my stress relief. But I also make it a point to take my dog for a walk every evening. So generally about 5 o'clock, I leave campus and go walk my dog. And then I have the evening. I can do more work at home if I want. But usually I just relax.
Yeah, I think this goes back to the question, and Ryan, I'll let you add more about time management. And I, as a military person, again, probably part of that, I like routine. So coming up with a healthy, good routine and trying to stick with it. I mean, I have a stepdaughter that's in high school and I try to get her on a routine and that doesn't work too well. So the better that you can be at making a healthy routine, not getting up at 12 o'clock in the afternoon and going to bed at 3 a.m. That is not a healthy routine. So making a routine and then incorporating, even if it's a little bit, like mine is working out and walking my dog and then getting beat by Ashley at Mario Party. So
Okay, I'm just gonna add on a little bit because we're running out of time, but I do agree with Dr. Lee where you create the routine throughout your day. So like in the morning, I usually wake up around 5, I go for a run, I go to the gym, and I'm usually in the lab by about 7 o'clock. But also on top of that, you don't want to kind of overdo, I guess, that weird type of routine and push yourself too far. You still want to be able to have the fun and lose in Mario Party every time you play. But I kind of started to have to start setting boundaries for myself. So like, I started going after this time in the day, it's going to be my time to kind of let myself be who I am, put down the academics, put down the research, and just allow myself to kind of be myself, kind of like how Taj is doing. I think that was a turning point for me in my academic journey as well, where I stopped trying to focus on school 24/7. I just kind of allowed myself to be a person after a certain point.
Speaking of which, I just want to segue to thanking this team from NAU for supporting the AEOP today and giving of your time and yourselves to share your stories and your research. To everybody who's attended today, thank you for participating, for joining in the chat, and we will capture all the great links and send them out to you, and they'll be also included with the video for those who could not attend. So Dr. Lee, Taj, Ryan, Ashley, we wish you the best in your endeavors, and we're excited to hear more from the CARE group. And we know we have a whole cohort watching right now, and we look forward to hearing more about their AEOP experience.